we will be discussing hydration of alkenes and hydration of alkynes. First, hydration of alkenes. Addition of water to multiple bonds. Addition of water to multiple bonds. Example, C double bond C or C triple bond C is referred to as hydration. If it is added to an alkene, then it is hydration of alkene. If added to alkene, that is a double carbon-carbon double bond. If added to C double bond C, hydration of alkene. Hydration of alkene. It is called as hydration of alkenes. What is the use of this hydration of alkenes? Hydration of alkenes is used commercially for the preparation of alcohols. Hydration of alkenes is used for the preparation of, for the synthesis of alcohols. For the synthesis of alcohols commercially. Alcohols commercially. How this particular hydration can be done? Hydration means addition of water. Water can be added to alkenes in the presence of catalytic amount of acid, catalytic action. By catalytic action of acid, water can be added to alkenes. Can be added to alkenes. This reaction is a reversible reaction because dehydration. For example, an alcohol is there. If you are going to dehydrate, you will be getting an alkene. So it is a reversible process. The process of hydration of alkene leads to an alcohol. The process of dehydration gives back the alkene itself. So it is a reversible process. It is a reversible process. Because alcohol formed by hydration can undergo dehydration to give back the alkene. So it is a reversible process. What is how to represent this reaction generally? General reaction. General reaction. Since it is a reversible reaction, we can able to write C double bond C plus water in the presence of an acid. Trace amount of acid is needed, just. It leads to alcohol. Since as a consequence of microscopic principle of microscopic reversibility, the mechanism of hydration as well as dehydration is identical in both directions. Is identical. Since microscopic reversibility, since since it is a reversible reaction, since reversible, according to microscopic reversibility principle, mechanism is identical in both the direction. The mechanism is identical. In both the direction. Hydration is the forward step, dehydration is the backward step. Since it is reversible, so microscopic reversibility principle operates, and so the mechanism is identical in both the direction. Kinetics of the reaction. Kinetics of hydration. Second order kinetics. It follows second order kinetics. The rate equation can be represented as a rate of decrease of olefin with respect to time is equal to rate constant concentration of olefin to the concentration of hydrogen ion. So 1 plus 1, 2 with respect to olefin first order and with respect to H plus ion first order. So overall it is second order kinetics. Okay, the acid that we are using, what kind of acid that can be used? Strong acid like sulfuric acid or phosphoric acid can be used in catalytic quantity, catalytic amount. For this addition reaction. Addition of water to alkene follows Markownikoff's rule. We know Markownikoff's rule, in which the negative part of the addendum goes to the carbon atom of the alkene containing less number of hydrogen atom. So example is there. Follows Markownikoff's rule. Markownikoff's rule. Hydration follows Markownikoff's rule. Hydration reaction of alkenes follows Markownikoff's rule. Example, propane. Upon adding H plus and water gives isopropanol. General mechanism of the reaction. general mechanism. Hydration of alkenes. Hydration of alkenes. Step 1. Addition of acid leading to the formation of pi complex as a transition state. It is a intermediate. You can say it's not a transition state, it's a positively charged species. It's a pi complex that is formed, pi complex plus H2O. You can see this H3O plus can be formed by the action of H2O plus H plus. H plus is from the acid source like sulfuric acid or phosphoric acid. So step 1 is the formation of pi complex. Step 2, the pi complex will be converted to a carbocation. That is the slow step and rate determining step. It's a positively charged species, this pi complexes, that will be converted to a carbocation. Now the water molecule that is there, that attacks the carbocation. This is a fast step. It's a fast step leading to an oxonium ion. Now this oxonium ion loses a proton and gives the final alcohol. With the removal of a proton. This is step 2. So there will be a pi complex that is being formed. The pi complex will be converted to carbocation, and the attack of nucleophilic water will be the fastest step. The formation of pi complex. Then the pi complex to carbocation, that is the slowest step. Slowest step is the rate determining step that we know. Next, the attack of nucleophilic neutral water molecule leads to an oxonium ion. That oxonium ion loses a proton and gives the alcohol in a fast manner. That is what the mechanism is about. It's a general mechanism. Now, mechanism can be written in different ways. But the thing is that this general mechanism, we always should remember there will be a formation of pi complex and then carbocation. Then only the attack of water molecule. So H plus from the acid will add. That is what we should know. For the reaction, for the addition of water to propane, we already have seen the example. It follows Markownikoff rule, and we will get the isopropanol. For this reaction mechanism can be written in a shorter way. Let us write the mechanism. Alternative mechanism, again say alternative mechanism. CH double bond CH2. The proton will be abstracted from the H3O plus ion by the alkene molecule, leading to a stable carbocation. We know in Markownikoff rule, a stable carbocation will be the ultimate result. So it's a secondary carbocation stable. Secondary carbocation stable will form. But this is a reversible step. This is a reversible. This is a slow step and red denominator. That is what that we have read. Plus water. Now water molecule have oxygen have lone pair on water molecule that attacks the carbocation formed. This will be a fast step. An oxonium ion will be the result. A positively charged oxonium ion. Oxygen doesn't prefer to have a positive charge, so nullification of positive charge takes place by the removal of proton, and that proton will be taken by the water molecule of the medium, leading to the formation of isopropanol plus hydronium ion. So this is the mechanism, alternate mechanism that we can able to see. This is also a fast step. So for propene to isopropanol, we can look at the reaction coordinate diagram, how these intermediates are getting formed, leading to the product alcohol from the alkene. Let us look at the coordinate diagram. Reaction coordinate diagram. For propene to isopropanol. Energy. So this is progress of the reaction. So here it is the reactant, that is propane and H3O plus reactants. So leading to the formation of first intermediate carbocation, secondary carbocation. Next, oxonium ion intermediate after the addition of water. This is actually slower step and the rate determining step. This is fast step after the attack of water molecule on the carbocation. Next, product formation. Hydronium ion and alcohol, isopropanol. So this is the energy diagram for the acid catalyzed hydration of propane molecule. Addition of alcohols in the presence of acid to form ether also resembles the same type of mechanism. Addition of alcohols. Addition of alcohols to alkenes in the presence of acid also follows same mechanism, also follows similar mechanism, follows similar mechanism